La la. All right, it's working. All right. Let me begin with a word of prayer. So, dear Heavenly Father, we thank you again for this time we have just to meet together, study your creation. I pray that you be glorified in what we do, and that we just all understand a little bit more about math together. In your name I pray, Lord Jesus. Amen. So, oh yeah, here's the attendance sheet. Very exciting. So, this is not the day before spring break, though. So, unfortunately, but spring break does not begin on Friday. So, like, nice try, though. So, let's talk about. Let's talk about function operations. All right. So function operations is, I sometimes call this, how to make new functions from old, because essentially what we're going to do is, if you're given, say f of x and g of x, both functions, right? Then we define, so maybe I can even forget the x for a second, just say f and g, both functions, all right? We can define f plus g, f times g, f minus g, f divided by g, and f composed with g as follows. Let me just, before I even write the formulas, let me give names to these things, okay? So this is the sum. This is the product. This is the difference. This guy is the quotient, or you could say fraction, right? So the sum of f and g, the product of f and g, the difference of f and g, the quotient of f by g, and then this guy is a little bit different. This is the composite of f with g. All right. How do you define these things? Here's how we define them. It's very silly, but f plus g of x is equal to what? F minus g of x, what's that equal to? F over g of x, what's that equal to? F times g of x, what's that equal to? And finally, f composed with g of x, what's that equal to? So, I mean, these definitions are pretty unsurprising except for the last one, I would say. So f plus g is really just how you do it. You do f of x plus g of x, okay? So to add two functions, you just add their formulas, all right? F minus g of x is defined by f of x minus g of x. So to subtract two functions, you just subtract their formulas. F over g of x, it's, well, just maybe what you're going to not be surprised to find out, f of x divided by g of x. There's a string attached to this. What is it? What condition do we need for x here? For what? For g of x not equal to 0, right? So we got that. F times g, well, that's f of x times g of x. Right? By the way, I should mention right now, f of x times g of x is equal to, these are just numbers, right? These are just numbers, so you can commute them. This is also equal to g of x times f of x, right? Because those are just numbers, you can commute them. And so identify then that that's g times f of x. So f times g is equal to g times f. We can multiply functions. Multiplication of functions commutes. All right? It doesn't matter f of x times g of x or g of x times f of x. It's the same thing. That's not the case for the last thing here. This composition is different. So what this circle, this is red composite. F composed with g of x is equal to f of g of x. So you take the rule for f and you plug the formula for g into it. All right? So this is generally not going to be equal to g of f of x, which would be g composed with f of x. See, those don't have to be equal. I'll show you examples of this. All right. So let's try this out. So example 1. Let's let f of x equal to the square root of, let's say, x squared plus 1. And let's let g of x be equal to 3x plus 2. Is there a question? Am I outside the... So you guys are sitting where the mean girl sat, but you're not that mean. It's not, I have no label for you guys. All right, let me stop my name calling. So this, what is f of x plus g of x equal to? So f plus g of x is equal to what?
3x plus 2 plus the square root of x squared plus 1.
Sure, and you did the g of x formula first and the f of x formula second, but that's fine because they commute, right? Totally fine. Now you got to be careful. If we do f minus g of x, then the order matters, right? So then this would be the square root of x squared plus 1 minus 3x parentheses plus 2. I'll put the parentheses in here to emphasize that minus has to distribute through the whole formula, right? So that would be f minus g of x. What would f times g of x be here? fg of x would be the square root of x squared plus 1 times 3x plus 2. All right, great. Let's see here. F over g. How'd that go? So we'd have the square root of x squared plus 1 divided by 3x plus 2 given what? Yeah, 3x plus 2 not equal to 0, which you guys were telling me is the same as x not equal to? Yeah, negative 2/3 is the what's got to give up. That's what's got to give. Now, this example is not especially helpful in terms of discussing domain. What's the domain for f? What's the domain for g? When is x squared plus 1 negative? Is x squared, let me ask it a different question. Is x squared plus 1 ever negative? It's not, right? Think about the graph. Y equals x squared plus 1. It's a parabola that has y-intercept 1 and it opens upward, right? The smallest x squared plus 1 ever is 1. So this square root is always taking the square root of a positive number. The domain's everything. So the domain of f is all real numbers. The domain of g is all real numbers. And likewise, the domain of the sum, the difference, and the product, these all have domain minus infinity to infinity, right? But the quotient, right, it's got what? The domain is everything except for minus 2/3, right? If you want to think about the domain. Usually what happens when you add functions, the domain of the addition or the subtraction or the product, it ends up being the intersection of the domains. Because you need both formulas to make sense, right? So like, if you had one formula which only made sense for numbers that are positive, and you had another formula which only made sense for numbers which are like less than 2, you'd end up with a domain which is like 0 to 2, something like that, this kind of thing. Anyway, I don't think I have any questions about domains, so let me stop blathering about that. Composite. That's the thing that's a little bit trickier. So here we go. F composed with G of x is equal to F of G of x. All right? So what is that? That is F of 3x plus 2. How do you do that? You take the formula, right? And you replace the x with 3x plus 2. Let me show you a notation that I've encouraged past classes to use, which is mathematically a little bit bogus, but not too bogus. So you can use it if you want. So here's what you could do. You could say, well, that's really f of g, right? And what is g? Well, so f of what? F of g squared plus 1, right? And then you can plug in what g is into that. I mean, that's logically what's going on. So if you want a process which is a little bit, easier to track, maybe you could do that, like basically make a substitution, right? What happens if we compose it the other way? What's g composed with f? Here. So I can think about this as like g of f, where f is equal to, the square root of x squared plus 1, right? What is g of f? Well, g of f would be 3 times f plus 2. So that's 3 times the square root of x squared plus 1 plus 2. It's fairly obvious, right, that this is not equal to that, right? What is it? So that begs a larger question. How do you tell when two functions are equal or not? Do you guys have any idea? I mean, this begs a more basic question, which shame on me for not already talking about, but this is actually really important logically. How do you judge when two functions are equal? Just work them out. Work them out, see if what you get's the same thing. That's actually kind of it. So the definition.
You don't want to sound so surprised.
I've said what I said. F equals to G. If and only if the domain of F is equal to the domain. I mean, if only if the domain of, they have to have matching domains, all right? And f of x is equal to g of x for each x in the domain of f, which is equal to the domain of g, just to beat a dead horse here. So a corollary to this is if you wanted to show two functions are not equal, it suffices to just show that their values are not equal even at one input, right? So for example, why f composed with g of x is not equal to g composed with f of x. I mean, the sort of, yeah, I mean, their formulas look different, right? But math is funny, right? Sometimes formulas simplify in unexpected ways. Let's just have like a more concrete, unavoidable evidence that they're not equal. Plug in a number. Like, what number should we plug in?
4.
4? 4, 2. The correct answer was 0. So f composed with g of 0 But we could have done any of the numbers you guys just suggested, but I'm lazy, so I'll do 0. F composed of g of 0 is what? We plug 0 into that, right? So square root of
2 squared is a 4 plus 1 square root. Yeah.
square root of 5, right? What's g composed with f of 0?
That would be 0 plus 1 squared plus 3.
Oh, come on. Stink. Oh, for a second there, I thought I had the same thing. Whew. Oh, goodness gracious. I didn't see the square root. I thought I had 5 and 5 for both. Which, yeah, your heart was, that was. So, I may be slightly more invested this than some of the students here. But no, I mean, so these are not equal, right? Therefore, these are not the same function. If we were unfortunate and we picked a value so that they're equal, we just wouldn't learn anything from that. We'd have to pick another value to see that they were not equal, you know? Yeah.
There are certain values where they'll be equal.
It's possible. I mean, we could try to figure that out. We'd have to solve the equation 3 times x squared plus 1 plus 2 equals to the square root of 3x plus 2 squared plus 1. You say 5?
I don't know, I just guessed.
I mean, we could try. I'm not super optimistic about this being solvable. I just made this stuff up, you know? And in the big scheme of all equations,
Isn't 2 squared 4?
so I get oh, this should be 12. I'm squaring both sides, guys. Eh.
21. Is it no, it's actually?
What is? Don't get lost in the fog. Is that what's being said? What is fog? If only I had calmly and carefully and slowly said words to describe what f composed of g was earlier in this lecture. I did. In fact, I even wrote it on the board. Here it is. So f composed of g is the composite of f with g. Sorry, this is give the back row abuse day. So, but it's the composite. So it's not. It's read f composed with g, or I sometimes read it f circle g. But it means we take the formula for one function and put it into the other. Yeah, it's like a substitution. That's what we actually. So we substitute. Substitution is the right word. I mean, we substitute the formula for g into the formula for f for this one. In this one, we substitute the formula for f into the formula for g.
So why does fog not equal off?
Because we just showed that if you plug in the number 0, the one gives you the square root of 5 and the other gives you 5, so they can't be the same function.
But if we worked out that problem, then we would get a number that when plugged into both would be equal.
Okay,
Yeah.
Then you would end up plugging.
It was just we were just messing around, see if we could find a point where they're equal.
Okay, I'm following.
I mean, can we? I don't know. I mean, maybe.
I think it depends. Depends on how good you are at randomly coming up with
Ooh.
an equation.
Yeah, probably not, though, because you're looking for a number. Man, I don't know. Well, I mean, here, give me a second. We'll feed it to Wolfram Alpha, see what it tells us. How about that? Photo math. You guys, you can photo math it if you want. I mean, it's not how I roll, but you guys and your photo math. Let's see here. What we got? We got square root of x squared plus 1. You guys will have to help me read it. Plus 2 equals to what? Square root of what is it? Parentheses 3x plus 2, quantity squared plus 1. close square root equal? Let's see. I don't quite have it yet, do I? Because I'm missing a 3 here. Don't make fun of Wolfram. How dare you? How dare you? Let's see here. So, hey, no solutions exist. So that's probably, whoa, really?
So there's no number.
Not even like, you got to understand, Wolfram Alpha looks for complex solutions and real solutions alike usually. There's not even a complex solution to this?
No.
Dang. Whoa. Whoa. Wow. Cool.
That's a real problem.
$300 in yen. There you go. $300 is 40,881 Japanese yen.
Wow.
This Wolfram Alpha has all kinds of stuff like this, like real-time data, currency exchange rates. You know, if you wanted to convert cubic yards to like cubic inches, it could do that. Check it out. 3 cubic inches is how many cubic yards?
Hey, Mr. Cook?
What? Yeah.
What if, for my page of notes for exam 2, I just made it a web page?
No, you are not allowed to use this website as your page of notes.
It's a page, not a page.
It is a,
It's a web page.
but I said that the page has to be 8 inch by 11.
Well, what if my computer is those like those?
You're going to find an 8 inch by 11 inch tablet. Let me know when you buy that, because then I'll change the rule.
643
So, yeah. All right, so let's see here.
So what I'm hearing is if I had done that and not told you and then showed up to the exam, you wouldn't have been able to change the rules till after the exam.
Well, I do explicitly say no electronic devices allowed. So, actually, I don't know if I have been saying that, but it's definitely going back on the next test. Let's see here. So, you've reminded me. Okay, so listen, guys. Let me spend a little bit of time here looking at the recommended homework with you guys.
Recommended homework already? We normally do that like in the last 10 minutes. What do you need? What do you need? I got it.
That's okay. I got it. I don't know what I need yet. I'm figuring it out, you know. All right, good enough. All right, so let's see here. Yeah, let's just talk about this one for a minute. So this is from section 2.7. This is on that transformation stuff we did last time. So you guys help me out. We're supposed to match each equation with the sketch of the graph down here. So x squared plus 2. Which one's that? Which one's x squared plus 2? Is it this one? B. It's B? Are you guys looking at the answers? Okay, good. Well, is it? I have the teacher's edition, so there's some answers over here sometimes, you know. Oh, okay, so yeah. How about B? A? Yep. C?
C is. Wait, is there more?
Guys, it's not
Wait, scroll down. Scroll down.
Yeah, C is C. Okay, C is none of the above, right? D?
D is C.
That's D, right? That one's that one.
Mr. Kirk, can you scroll down a little
I will in a second. 2, which is this one? It's this one, right? It's this one. Yep. See, compare E. Listen, guys, compare F and D. See, F is more pinched. This one's more a little bit not so pinched. So D, if they're on the same scale, I'm pretty sure D is F, right? Oh, so
G is the, wait.
it's so confusing.
The letters.
Oh, but just watch what I'm doing. You know. How about this one? X minus 2 squared plus 1. Which is that one? It's. Here's a more specific question. What's the vertex of this parabola? It's nope, not negative 2, 1. It's 2, 1. 2, 1. So this one is none of the above. This one is negative 2, 1. H is E. This one is that one. And yeah, I'll go down. You guys for.
Oh, yeah.
So indeed, this one is that one. G is matching to C is matching to G. I wish they'd use numbers up here and letters down here rather than letters for both. It's, come on, people. H is, oh, you said H is G. This H.
Well, G is H.
Okay, this G is H down there. Okay, so I've learned that when I put a question like this on the test, I must use letters for one and numbers for the other. Otherwise,
F is I.
goodness, why would you, why? Like, why?
I know I was on
Why?
I think it would be easier.
13.
They're trying to purpose.
Well, okay, fine, let's do 13 for a minute. So, fine. Let me try to zoom out a bit so you can see everything. So this is the square root shifted what? 3 units to the left. So you guys told me it was what? G? Where's G? Yeah, okay, yeah. A is G. B is what? A is D, yep, okay. C? It's my thumb. What's that? C is E, yeah. So let me just pause for a second. Like, how do you guys know this? You're just taking the square root graph and you're shifting it up 3. That's shift up 3, right? Yeah. This is square root graph stretch 3, right? Yeah. So it's B, very good. This one is square root graph flip over the x-axis, C. C, very, yep, C. This one we're shifting right 3 units, so it's A, yep, A, very good. This one is, we shift right 3 and then up 2. That's H, very good. This one, I just did that. Wait a minute. Oh, the plus 3, not minus 3. This is shift left 3 and then up 2. F. Oh, F? Where's F? Oh, this one. Yeah, that one. F. And then this one is shift right 3 and then down 2. That's that one. Okay. I'm going to move on. Yep.
So like when we were talking about the function operations, and if you say that you want the unsimplified formula for it,
Yes.
do you not want us to solve?
The unsimplified formula is the unsimplified formula. So what I mean by that is like here. You can still see this one, right? So unsimple. In other words, I don't expect you to multiply this out.
Okay.
If there was like, you know, if it could be factored and canceled out, I don't care about that. I'm just looking for literally f of x plus g of x, or f of x minus g of x, or f of x times g of x, or
You just want to see that written down.
just the operation. No, you don't have to simplify past that. There are applications and things we might do where the simplification would be important, but for the sake of that problem, you don't. So problem 57 and 61 merit a discussion. Here's something I haven't told you guys about yet. So we talked about different kinds of functions, right? We have polynomial functions. We'll soon be talking about rational functions, right? We talked about linear functions, quadratic functions. There's more generally, like if you have a function that's based on some finite combination of square roots and division, multiplication, things like this. It's called an algebraic function. So most everything we've looked at falls under the category of algebraic function. There are more general terms, though, that we can think about. So here's one characteristic. You can have definition. Given f with symmetric domain about the origin. Number one, f is even if f of minus x is equal to f of x for all x. 2, f is odd if f of minus x is equal to minus f of x for all x. So this is what problem 50, 57, and 61 are about in the homework, right? So I'll leave those for you guys to work. Let me try out 63. So number 63, let's decide if this function, we've got what? F of x is equal to x plus 1 over x to the 5th, right? And the question is this function even or odd? Odd? And why do you say that? Because it's odd powers. That actually turns out to be true, but let's find out why. F of minus x is minus x plus 1 over minus x to the 5th power, right? But that is minus x minus 1 over x to the 5th. So you can factor out that minus 1 and write that as x plus 1 over x to the 5th, which of course is equal to minus f of x. But you're right. If the formula is just made of odd powers added or subtracted, it will be an odd function. So odd power functions are odd functions. And likewise, if we just have even powers, it'll be an even function. That's also true. But, you know, this only goes so far in terms of like these kinds of heuristics only go so far. Like, let me see here. So for example, what example am I on here? Did I ever number? Well, I guess this is example 1. It's got to be example. What? Example 2? All right. Well, this was example 2, right? So 3. It doesn't matter, right? Anyway, so how about this? What if I had f of x equals, you know, x cubed times x squared plus 1? Is this function even or odd? You say even because it's got an x squared in it, right? I say odd because it's got an x cubed in it. Which of us is right?
Well, because whenever you go multiply it out, x.
But isn't even times odd even?
What?
2 times 3, 2 times 3 is 6. That's even, right?
Yeah. So
Yeah. But that's not how this works. You got to think. So
oh wait.
the problem with what I said is I'm conflating the use of even and odd for whole numbers or integers with even and odd for functions, and it doesn't quite work the same way. Yeah.
It's odd.
It is odd. You're correct, because this is minus x cubed times x squared plus 1, right? Because the square eats the minus, but the cube does not. It spits the minus back out, and all together we have minus f of x. So what Beth Ann is saying is correct. It is an odd function. So yes, the product of an even function and an odd function is odd.
So if x
Yeah.
is negative and it ends up being negative as a whole, that's how you know it's even. Or odd.
Yeah, so to decide whether it's even or odd, you have to evaluate f at minus x and see if it works back to f of x or f of minus x. Now, There are other functions, like example 4 here. If we look at f of x equals to, say, x squared plus, 1 over x, what's f of minus x? Yeah, so that's x squared minus 1 over x, right? So if you look at this example here, this function is neither even nor odd. See? Because it's not equal to f of x, and it's not equal to minus f of x. In fact, this is the case for most functions. Even in odd functions, they're pretty special. It's not usually the case that your function's even or odd. Only special ones are. Okay? So that's true. So I just wanted to say a word about that. Let me go on here with this short tour of your recommended homework. So this is kind of this number 95 is going to be what? Is this a square root or is it an absolute value?
Absolute value.
Absolute value. What would the formula be for 95?
It would be
Negative,
plus 1. So it'd be
negative x minus 1, and then out of the absolute value plus 3.
So absolute value of x what?
So negative absolute value of x,
Negative absolute value of x, right? Yeah.
and then plus 1.
Plus 1 inside the absolute value, right?
Yeah, inside of it, outside of it, plus 3.
Plus 3. That is correct. I think. One thing to check on is, does it have slope 1? Yeah, it's a slope 1 one, so it's not been like compressed or stretched, yeah? What? Oh, okay. Doesn't like to be stepped on, apparently. Yeah, 98 has been stretched out. That's a good point. This one, I think, is I think it's a half. So you'd have like 1/2 the absolute value of x minus 2, all minus 1. So number 98. Number 98. While I'm at it, we'd have y equals 1/2 the absolute value of x. It's shifted over 2, so minus 2, and it's down 1. Okay, anyway, move on here. All right, so now here's the homework that I wanted to look at. Specifically, I wanted to look at these. This problem right here. This is what I wanted to look at with you guys. Talk about how to do these. These are a little bit different. Okay, so like we're supposed to calculate, A, B, C, and D for this graph, right? We got f plus g of 2, f minus g of 1, f times g of 0. So can we do these? Exactly. What are f and g here? So what would f plus g of 2 be? It would be f of 2 plus g of 2, right? What are those, though? Here's my graph, right? This is the graph of f. This is the graph of g. F of 2, I look at here's 2, right? Where is f when you're at x equals to 2? Right there. What's that? 4, right? So f of 2 is 4 from that point that I'm pointing at right now, okay? So f of 2 is 4. What's g of 2? Yeah, g of 2, down here it's minus 2, right? So even though we don't have a formula for f and g, if we have a graph, we can figure these questions out. What's f times g of 0? This would be f of 0, g of 0, right? So let's see here. What is f of 0? 0. What's g of 0? -4. But actually, once you know f of 0 is 0, it doesn't really matter, right? So the answer is 0. Let me do a composite one. That's not on this list, but let's do that one, okay? What would f of, well, let's say g of f of 0 be? Oh yeah, sorry, this is g composed with f of 0 is equal to this, right? What is f of 0? Well, we just figured that out, right? F of 0 is 0. So this would be equal to g of 0 as it happens, which is, you guys just told me, -4. Let's try another one here. What would g composed with f of 1 be equal to? That would be equal to g of f of 1. What is f of 1 equal to? F of 1 apparently is equal to 1. So that's actually g of 1, which is equal to -3. So let me do a composite with the other graph. I think composite tends to give you guys much more trouble than the other operations, right? Composite is like way more complicated than the addition, the subtraction, or the multiplication for sure, right? Addition's kind of hard. Okay, I'll allow it. Let's see here. How about well, I'm trying to find something interesting. G of f of 1. So in other words, g composed with f of 1 equals what? And so I want to do for number 34. So look at number 34. Let's see. What is f of 1? Here's f, right? F of 1 is 2, right? F of 1 is 2, right there. F of 1 is 2. So what is g of 2? 2, yeah, -2, right. All right. I think we've done enough of this at this point. We can go on here. So that's pretty much how you do the homework in these. Oh no, there's still another topic I got to cover. So here, this is the other way other way that you can characterize functions with like a table of values. See here, how would you figure out what f plus g of 2 is for this one? It's f of 2 plus g of 2, right? Exactly. You look down here, you go f of 2 is 7, g of 2 is -2, so the answer would be 5, and so forth. All right. So that's sometimes a nice way to do problems with the table values. Let's see here. All right. Well, I think that's. Well, we should do some more composites, right? So let's try those out. So I'll do one more composition. We'll be doing more composition in the future anyway, but here's one more for today. What happens if, like, let's do number 73, right? So we've got f of x equal to -6x plus 9. G of x is equal to 5x plus 7. Let's look at what is the composite of f and g, f of g of x. So I can think of that as f of g, where g is equal to 5x plus 7, right? And so that's minus 6g plus 9, which is minus 6 times 5x plus 7 plus 9. And I don't know, it's kind of fun to simplify this one. So this is minus 30x. Minus 42 plus 9, I guess, is minus 31. All right. So that's the composite of these two lines. If you that's actually kind of interesting, right? If we compose two lines, what do we get? Right? do do do. All right. I think I can erase these, right? What? Oh, I guess I should have asked if you guys moved the camera over there, didn't you? Right? I should have asked before I erased, I guess, but it's here. So let's calculate. We've got x to the fourth minus 2x cubed minus 14x squared minus 10x plus 25, all right? And I'm going to call the thing under the radical, under this division sign, I'm going to call that f of x, okay?